Hi, this is Mr. Moser. Welcome to my podcast for Chapter 4, Section 3. Have you ever looked up in the sky and seen the moon, and you see the seemingly different shapes of the moon, how it goes through just a sliver of a moon here, and it grows and grows and grows until we get up all the way up to where we have a full moon, and then it seems to go away until we have no moon right here. It's all black. Those different shapes are called phases. We call them phases of the moon. And a lot of times you can see these different phases if you were to look at calendars. They sometimes will have what phase of the moon it is, or we're expecting to have. Have you ever seen this phase of the moon right here? The moon, it doesn't produce its own light. And so the moon only reflects light from the sun. When the moon passes between the earth and the sun, the side that faces the earth is in darkness. And this phase is called the new moon. Or sometimes it's called the black moon because the whole moon appears to be black. So really quickly, I'm just going to go through here and kind of show you what we've got here. These up here are what we call waxing crescents. When we get to here and we have the moon as a quarter, that's called the first quarter. And then over here, we're getting bigger and bigger and bigger. We would call that a waxing gibbous. This is the full moon. And then we have our waning gibbuses. Let's see, I'm going to go over here. Here, we're about a quarter. That's our last quarter. And then these guys here are waning crescents. And then the new moon. So those are the different phases of the moon. Okay, so what I want you to do now is I want you to stop the video. I want you to pull out your worksheet that's entitled Phases of the Moon. And now that we've gone through all those phases of the moon, it'll make sense for you to do that worksheet now. As the moon revolves around the Earth, and the Earth and the moon revolve around the sun, sometimes the sun's light is blocked by the moon, causing a shadow. And when the moon is between the sun and the Earth, the moon casts a shadow on the Earth. And so here we have, here's the sun. The moon is in between us and the sun, and it will cast a shadow on the Earth somewhere. And when that happens, we're having a solar eclipse. And solar eclipses can be very, very beautiful. This is a picture of a solar eclipse here, where we have the moon that's blocking out the sun, and all you can see is the corona. Okay, so here we have the moon that's blocking out the sun, and you could ask yourself, what phase was the moon when it caused this solar eclipse? Well, since we know that the moon reflects the light from the sun, so that we see the light on the moon, when it is completely facing away from us or in between us and the sun, that would be at a new moon phase. Okay, so now what phase is the moon in when we have not this situation here, but where the moon is on the opposite side, as in this situation, where we have the sun, the earth, and then the moon. In this situation, we're at what we would call the full moon, because the sun would be fully shining on the moon and we would see it there. So scientists, they call the eclipse that happens here, where the shadow of the earth is on the moon, they call that a lunar eclipse. And scientists call the eclipse that happens where the moon is eclipsing the sun as a solar eclipse. So down here on this little diagram, you can see that where the light from the sun is totally blocked out and shining on the moon, so it's no longer shining on the moon, we call that the umbra. And where it's only partially blocked, here and here, we call that the penumbra. And you can see it in these three different phases here. We have here would be the umbra, this would be the penumbra on the outside, and the penumbra on the outside, where it's only partially blocked. Now that we've learned about eclipses, stop the video and pull out your worksheet entitled Lunar and Solar Eclipses and finish that. Okay, so the rise and fall of the oceans are called tides. Tides are caused by the moon's gravitational pull on the earth. And so here we have the moon. The moon is it's a large body in space. It has a lot of gravity, and it exerts a pull on the earth. And so what happens is the water that surrounds the earth, since our earth is mostly made out of water, it gets kind of bulged out on the sides that are facing the moon. It kind of pulls that water up. And we have 2 tides a day. So the moon's gravitational pull actually pulls the water up, but the earth, which is more solid, it doesn't move towards the moon. When the earth rotates, both the land and the water rotate together, and the side of the earth that's nearest the moon has the greatest gravitational pull from the moon. The moon's gravity pulls the water slightly away from the earth on the moon side and pulls the earth slightly away from the water on the other side. This causes 2 bulges in the oceans. This is a picture of the Bay of Fundy, and you can see this is a picture at high tide, and here's a picture at low tide. And the Bay of Fundy has the largest tides in the world. And you can see that here, I mean, same picture, same area, just different times of day. And the water is completely filled up this bay, and then at low tide, the water drains out and actually leaves these boats sitting in the mud. So. Okay, so now that we have finished learning about tides, you should stop the video and work on your worksheets for the high and low tides and the neap tide and spring tide. Okay, let's go ahead and review. How is the relative motion of the Earth and the Moon and the Sun related to the phases of the Moon? So when we have the Earth here and the Sun is out here and the Moon is in between us here, the Moon reflects the light from the Sun back down to the Earth, and when all that light is focused on this side of the Moon over here, we're at the new Moon, or we wouldn't see any light being reflected back towards the Earth. If the Moon was over here, we would have half of the light, okay, and this would be a waning quarter, and then over here we would have this half, that'd be a waxing quarter, and then over here we would have the full moon. And then in between here we have our crescents and our gibbuses. Okay. Okay, eclipses. What are eclipses? Back to our picture here. Okay, eclipses happen when the shadow is created from the moon, or vice versa from the Earth on the moon. Okay, so here's the moon here. We have what we would call a solar eclipse. On this side over here, and if the moon was over on this side and was being eclipsed, then we would call that a lunar eclipse. When would you be able to see a lunar eclipse? You would be able to see a lunar eclipse when the sun, the Earth, and the moon are right in this fashion here. And so the Earth is in between the moon and the sun. We would get a lunar eclipse. Solar eclipses happen when we have the sun, the Earth, and the moon is in between the sun and the Earth. Okay? Okay, how does the moon affect tides on the Earth? The moon affects tides on the Earth by its gravitational pull. Here's the moon. Here's the Earth. We have this gravitational pull, and gravity pulls the water on the Earth out this direction, kind of gives it a bulge. And then on the opposite side, gravity pulls the land in a little bit, and we get another bulge out on the other side. So we have two tides a day. One's caused by the water being bulged out, the other is caused by the Earth being kind of sucked in a little bit. And I hope that was helpful to you.